In the cold, silent void, 13 billion light-years from our pale blue dot, something impossible stares back. The James Webb Space Telescope, a marvel of human ingenuity, has plunged its infrared gaze deeper into the cosmic abyss than any instrument before it. What it has found there is not merely surprising, it is a direct affront to every law of physics we thought we understood, a brutal deconstruction of our cosmic narrative. Ancient galaxies, impossibly mature for their age, black holes that predate the very first stars, and rogue signals screaming across the void from worlds that shouldn't exist. This isn't just about discovery, it's about a fundamental re-evaluation, a crisis unfolding at the very bedrock of scientific consensus. For decades, the intellectual architects of cosmology believed they had a firm grasp on the universe's expansion rate. The venerable Hubble Space Telescope delivered one key measurement. Elegant mathematical models offered another. Everything, it seemed, clicked into place like pieces of a grand celestial jigsaw puzzle. Then, Webb looked, and the puzzle shattered into 1,000 jagged fragments, revealing a universe profoundly more unsettling than we had dared to imagine. Part 1, The Expansion Crisis, a universe in disarray. The cosmos, it turns out, is expanding at two distinctly different speeds, depending on where and how you measure it. Imagine a colossal balloon being inflated, but the upper hemisphere inflates twice as fast as the lower. Such a scenario, by all conventional understanding, should be impossible. The very laws of physics, the hallowed tenets that govern universal behaviour, demand a uniform expansion across the tapestry of space-time. Yet Webb, with its unprecedented precision, confirmed what many astronomers had privately feared, a fundamental schism. When researchers triangulated the expansion rate using distant pulsating stars known as Cepheid variables, they derived one precise number. When they calculated it, instead, from the cosmic microwave background radiation, the universe's ancient echo, they obtained a number so divergent, so utterly irreconcilable, that it plunged the scientific community into a state of profound disquiet. This isn't a trivial statistical anomaly. We are grappling with a discrepancy so monumental that it screams a terrifying truth.
This data makes no sense.
Our most fundamental understanding of reality is flawed, perhaps catastrophically so. Scientists, ever the masters of understatement, call this the Hubble tension. But that clinical term fails to capture the true existential horror of the situation. This is no mere calibration issue, no simple measurement error to be ironed out by further observation. After an exhaustive, meticulous study encompassing over 1,000 Cepheid stars across 5 distinct galaxies, stretching 130 million light-years into the cosmic tapestry, the contradiction remains stubbornly defiant.
Stated that the
implications are nothing short of staggering. Either the very models that form the bedrock of our cosmic understanding are fundamentally broken, or there is an unknown, unseen force actively tearing reality apart piece by piece. Dark energy, the enigmatic entity currently invoked to explain the universe's accelerated expansion, might be operating in ways far more complex and localized than our current simplistic models allow. Could it be that certain regions of space are expanding faster than others, creating invisible, cosmic rifts in the fabric of existence? Dr. Adam Rees, the Nobel laureate and lead researcher who first brought this crisis into sharp focus, articulated the dilemma with chilling clarity. With measurement errors ruled out, what remains is the real and exciting possibility that we have fundamentally misunderstood the universe. One might argue that the word exciting feels profoundly misplaced when confronted with such a destabilizing revelation. If our core understanding of cosmic expansion is erroneous, then every calculation predicated upon
What is that?
the universe's age,
No, that can't be
its ultimate
right.
size, its eventual fate, becomes suspect. Webb's unparalleled precision has irrevocably stripped away any shred of doubt regarding the integrity of these measurements. Both Webb and Hubble, independently, confirm the same impossible contradiction. The universe expands, yes, but it does so in a manner that brazenly violates the physics we've painstakingly constructed. This single discovery alone would be sufficient to shred every cosmology textbook currently in print. But Webb, as it turned out, was only just getting started. As the telescope continued its relentless survey of deep space, it began unearthing objects that shouldn't exist, behaviours that defy any rational explanation, and phenomena that suggest our reality is far stranger, more dynamic, and arguably more dangerous than we ever dared to imagine. The expansion crisis was merely the opening act in a series of discoveries that would force the scientific establishment to question everything it thought it knew about the cosmos. But what Webb found next made the Hubble tension seem almost quaint by comparison. 6 impossible monsters, gargantuan and ancient, float in the cosmos's earliest light, actively rewriting the very laws of galactic evolution. Part 2. The Universe Breakers, Impossible Galaxies. When James Webb meticulously aimed its infrared eyes at a seemingly unremarkable patch of sky near the Big Dipper, astronomers were anticipating the sight of tiny nascent baby galaxies, tentatively stumbling through their first billion years of existence. Instead, they discovered 6 immense, fully mature star systems, galactic titans that simply should not have had the time to grow so large, so early. These cosmic leviathans boast nearly as many stars as our own Milky Way, yet they coalesced and matured when the universe was a mere 3% of its current age. Imagine attempting to cultivate a full-sized, majestic oak tree in just 3 short months. That, in essence, is the cosmic impossibility these galaxies achieved. Star formation is a protracted, arduous process. Gravity requires millions, even hundreds of millions of years to painstakingly pull together sufficient gas and dust to ignite the inferno of nuclear fusion. Yet, these 6 systems, dubbed universe breakers, somehow fast-tracked their development, emerging as galactic behemoths while the cosmos was still in its chaotic infancy. The discovery, almost conspiratorially, happened by accident. Astrophysicist Dr. Erica Nelson was meticulously scrutinizing postage stamp-sized sections of Webb's deep-field images when her eyes snagged on several fuzzy red dots, impossibly bright. In the lexicon of astronomy, redshifted light typically signifies immense age, stretched and attenuated by the universe's relentless expansion during its multi-billion-year journey to Earth. But these objects were an unsettling paradox, both ancient and blindingly luminous, a combination that defied every established explanation. Each of these monster galaxies contains an unfathomable 10 billion to 100 billion stars. To achieve such colossal sizes so rapidly, they would have had to churn out hundreds of new stars every single year for hundreds of millions of years. Our Milky Way, for stark comparison, manages to birth a paltry 2 new stars annually. These ancient systems were stellar factories operating at production rates that, according to the inviolable laws of modern physics, should be impossible. The team, in a gesture reflecting the profound challenge these objects posed, informally christened them universe breakers because they threatened to utterly dismantle our understanding of how cosmic structures form. According to every simulation, every painstakingly constructed model scientists have devised, matter in the early universe should have clumped together slowly, methodically. Small embryonic structures would gradually merge, incrementally accumulating to form larger ones over billions of years. These 6 galaxies brazenly toss that entire timeline out the window. They suggest that the early universe was capable of a level of organization and complexity that cosmologists never, in their wildest equations, imagined possible. Either there exists a completely unknown mechanism for hyper-accelerated galaxy formation, or our most fundamental assumptions about cosmic evolution are catastrophically, irrevocably wrong. The discovery raises terrifying questions, casting a dark shadow of doubt on dark matter's true role in early cosmic development. If galaxies could swell to such enormous masses so quickly, it implies that dark matter was clumping together, exerting its gravitational tyranny and pulling in regular matter at rates far exceeding current theoretical predictions. The invisible scaffolding that shapes our universe might be far more violent, more dynamic, and ultimately more unpredictable than we realized. Dr. Joel Lear, one of the astronomers studying these baffling objects, perfectly encapsulated the magnitude of the problem. We looked into the very early universe for the first time and discovered something so unexpected that it creates genuine problems for science. But confirming whether these truly are galaxies, and not some other exotic phenomenon, required additional observations with Webb's spectrograph. And what those follow-up studies revealed would prove even more disturbing than anyone anticipated. Part 3. Cosmic Monsters, the Black Hole Anomaly. A monster with the mass of 50 million suns is wandering through the cosmic void, completely alone, and it's actively rewriting the history of the cosmos. Deep in the universe's nascent youth, James Webb unearthed something that should not exist according to every prevailing theory of black hole formation. Designated Jade's BH1, or QSON in its popular moniker, it is a supermassive black hole with virtually no galaxy surrounding it. It is, in essence, naked, drifting through space without the typical retinue of billions of stars that normally accompany such colossal objects. Most supermassive black holes are the gravitational anchors at the centres of galaxies, surrounded by swirling disks of stars, gas and dust. They form a delicate symbiotic relationship with their galactic hosts, growing in tandem over eons through an intricate cosmic ballet of gravity and star formation. QSON, however, breaks all those rules. This solitary cosmic wanderer contains enough mass to equal 50 million of our suns, compressed into a region smaller than our entire solar system. To put that into terrifying perspective, if Earth were the size of a marble, QSON would still be invisible to the naked eye, yet contain more matter than exists in hundreds of billions of normal stars. What makes this discovery truly disturbing is its sheer antiquity. QSON exists in the universe's childhood, a mere 600 million years after the cataclysmic Big Bang. Traditional black hole formation necessitates the violent death of massive stars, a process that requires waiting for the first generation of stars to form, live their brief, brilliant lives, and then explode in spectacular supernovae. That entire process should, by all calculations, consume far longer than 600 million years. Dr. Roberto Maiolino, the Cambridge astrophysicist instrumental in identifying QSON, described the find as completely off the scale. The object challenges every model scientists have painstakingly constructed for how supermassive black holes grow and evolve in the early universe. 3 unsettling theories currently vie to explain QSON's impossible existence, and each one is more unsettling than the last. The first posits that some black holes can form directly from the gravitational collapse of massive gas clouds, cunningly bypassing the entire stellar phase. The second proposes that intermediate mass black holes somehow grew at impossible rates, consuming matter faster than physics should allow, as if gorging themselves in a cosmic feeding frenzy. The third theory, however, is the most disturbing of all. QSON might be a primordial black hole, forged in the universe's first chaotic seconds during violent fluctuations in space and time immediately after the Big Bang itself. If true, it means QSON has been lurking in the cosmic darkness since the very beginning, a silent predator, waiting 13 billion years for stars and galaxies to form and illuminate its eerie presence. QSON, horrifyingly, is not unique. It is one of hundreds of similar objects that Webb has identified, appearing as little red dots scattered throughout the early universe, each one a potential cosmic monster that defies explanation, glowing with the terrifying light of matter being shredded and superheated as it spirals into their inescapable gravitational maws. The pervasive existence of these naked black holes suggests that the early universe was far more chaotic and violent than cosmologists ever imagined. Instead of the gradual, orderly formation of cosmic structures, we might be looking at direct evidence of primordial catastrophes that forged massive black holes even before the first stars had a chance to exist. If QSON truly is a primordial black hole, it represents something far more ancient, more alien, and more fundamentally unsettling than any galaxy or star. But QSON wasn't the only impossible black hole that Webb would discover lurking in the cosmic deep. Black holes, older than the first stars themselves, are now lighting up the universe, and they might have been there since the very moment of creation. Part 4. The Sleeping Beauties, Galaxies Stuck in Time. Scientists have long operated under the assumption that supermassive black holes coalesced after the first generation of massive stars collapsed in spectacular terminal events. This entire cosmic cycle, they calculated, should take hundreds of millions of years, as gravity slowly, inexorably pulls together enough matter to ignite nuclear fusion. Stars are born, live their brief but brilliant lives, and then explode in supernovae, leaving behind their dense stellar corpses. But James Webb has now found irrefutable evidence of supermassive black holes existing, when the universe was barely 400 million years old, far too early for this traditional, star-death-driven formation process to conceivably work. Dr. Andrea Ferrara and his team at the Superior Normal School in Pisa, Italy, have proposed a radical, almost heretical solution to this cosmic puzzle. What if black holes, not stars, were the first significant sources of light in the universe? What if primordial black holes forged in the chaotic, high-energy first seconds after the Big Bang were already lurking in the darkness when the cosmos was still in its infancy? These hypothetical primordial black holes would have formed through a completely different mechanism than their stellar counterparts. Instead of collapsing stars, they would have emerged directly from extreme density fluctuations in the primordial soup of energy and matter that existed less than 5 seconds after the universe's violent birth. Picture the early universe as a furiously boiling cauldron of raw energy, with certain regions becoming so incredibly dense, so gravitationally stressed, that they collapse directly into black holes without ever needing to form stars. The evidence Webb has meticulously gathered lends chilling credence to this bizarre scenario. Many of the bright objects observed in the early universe appear point-like rather than extended, strongly suggesting they are powered by compact sources, actively feeding black holes, rather than diffuse distributed star formation. When gas falls into the accretion disk of a black hole, it heats to scorching temperatures, emitting brilliant light that, from vast distances, can appear almost identical to the light emanating from newly formed stars. If this theory holds true, it means primordial black holes were voraciously feeding on the universe's very first gas clouds, growing larger and more massive while simultaneously illuminating the nascent cosmos. These primordial monsters would have been patiently sitting in the dark for hundreds of millions of years, essentially waiting for the universe to evolve sufficiently to provide them with their first meal. The implications are staggering, a seismic shift in our cosmic origin story. Primordial black holes could elegantly explain how supermassive black holes grew so colossal, so quickly in the early universe. They had a head start of hundreds of millions of years, an unfair advantage, allowing them to reach enormous sizes before the first galaxies even began to form around them. But this scenario raises even more disturbing questions. If primordial black holes were, in fact, common in the early universe, they might still be out there today, invisible, undetected, silent cosmic stalkers. Some could be wandering through our own galaxy, ancient alien relics from the universe's violent birth that predate every star we can see. These primordial monsters represent a fundamental paradigm shift in our understanding of cosmic evolution. Instead of a universe that gradually built complexity from simple beginnings, we might be looking at a cosmos that was born with powerful, massive objects already embedded in its fundamental structure. The definitive detection of primordial black holes would also provide crucial, unprecedented insights into the physics of the Big Bang itself, revealing conditions in the universe's first moments that we can at present barely imagine. But Webb's surveys of these ancient black holes revealed an even stranger phenomenon, one that challenges our understanding of gravity itself. Two galaxies are locked in a cosmic train wreck, a collision so profound it is actively creating physics we've never seen before. When astronomers first spotted the celestial object they informally nicknamed the Infinity Galaxy, its surreal, intricate shape immediately seized their attention. This cosmic oddity displays two compact red nuclei, each enveloped by glowing rings of gas and dust, creating a perfect figure-eight pattern that uncannily resembles the mathematical symbol for infinity. But the galaxy's unusual, almost artistic appearance was merely the preamble to its deeper, more disturbing mysteries. The Infinity Galaxy was forged when two massive disk galaxies collided head-on in a cataclysmic cosmic crash that began millions of years ago. Galaxy collisions, while dramatic, are not uncommon in the dynamic evolving universe. But this particular smash-up has birthed something utterly unprecedented. Instead of the typical chaotic merger that often obliterates the individual identities of both original structures, these two galaxies have maintained their distinct individualities, yet simultaneously created something entirely new, a gravitational anomaly that defies expectation. What makes this collision truly bizarre, what pushes it into the realm of the impossible, is the astonishing location of its supermassive black hole. In normal galactic mergers, the central black holes from both galaxies eventually spiral toward each other, either coalescing into a single, even more massive object or, in rare cases, ejecting one from the system entirely. The infinity galaxy breaks this pattern completely, presenting a black hole suspended directly between the two galactic nuclei, floating in a vast expanse of glowing hydrogen gas that has been violently stripped away from both galaxies during their apocalyptic embrace. This positioning, by all gravitational logic, should be inherently unstable. The black hole should, inexorably, be pulled toward one nucleus or the other, not hovering inexplicably in the middle, like a cosmic referee overseeing the galactic crash. Dr. Peter van Dokkum and Dr. Gabriel Bramah, the astronomers who first identified this impossible system, believe they are witnessing something truly extraordinary: direct collapse black hole formation occurring in real time. Instead of forming from the protracted death of massive stars, this black hole might have formed directly from the gravitational collapse of an immense, super-dense gas cloud, itself a direct consequence of the galaxy collision. The process works like a cosmic avalanche. When the two galaxies slammed together, they created enormous, turbulent streams of gas flowing between their cores. Under precisely the right extreme conditions, these gas streams can become so massive, so incredibly dense, that they bypass the stellar phase entirely, collapsing directly into a black hole without ever forming a single star. It's like watching a cosmic implosion so powerful, so immediate, that it creates its own gravitational trap. This direct collapse mechanism could resolve one of Webb's most puzzling findings in the early universe: the existence of supermassive black holes that are far too massive for their age, having grown to enormous sizes faster than traditional formation models permit. If black holes can form directly from collapsing gas clouds, they could achieve supermassive status much more quickly than previously thought possible, given that they start with an enormous seed mass. The infinity galaxy, therefore, represents a unique, real-time laboratory for studying this exotic formation process. The black hole, incredibly, appears to be actively feeding on the gas flowing between the two galactic cores, visibly growing larger as the collision continues. Radio observations unequivocally show intense energy emissions emanating from the precise location where the black hole should be, confirming its active consumption of matter. But the most disturbing aspect of the infinity galaxy collision isn't what we can see happening now. It's what this discovery suggests about the violent, formative processes that shaped the early universe. If direct collapse black hole formation was a common occurrence during the cosmos's turbulent youth, it means the universe underwent a phase of incredible violence and chaos that we are only just beginning to truly comprehend. And that violence, it turns out, left behind objects even stranger than wandering black holes. Part 5. The Rogue Worlds, Orphaned Planets and Their Mystery. Hundreds of orphaned worlds are drifting through space, not alone, but in unsettling pairs, and they are broadcasting radio signals that, by all known physics, simply shouldn't exist. James Webb's meticulous surveys have identified over 500 free-floating planets in the Orion Nebula that do not orbit any star. These cosmic wanderers, each roughly the size of Jupiter, are believed to have been violently ejected from their original solar systems, now condemned to drift through the cold, endless emptiness of interstellar space. What makes them truly bizarre, however, is the revelation that many of them travel in pairs, orbiting each other at distances ranging from 25 to 400 times the distance between Earth and our Sun. Scientists struggling to categorize these anomalies have dubbed them Jupiter mass binary objects, or jumbos. They shatter every theory of planet formation we have painstakingly developed. Planets typically form within the swirling disks of gas and dust, surrounding young stars, slowly accreting material until they reach their final size. The intricate gravitational dance required to create binary planets, especially those without a parent star, should be incredibly rare, if not impossible. Yet Webb has found dozens of these cosmic couples. The mystery deepened, plunging into the realm of the truly inexplicable, when astronomers pointed sensitive radio telescopes at these paired planets and discovered something unprecedented, something that sent shivers down the spines of researchers. Several jumbos are emitting potent radio signals with patterns never before observed from planets. These are not the typical faint emissions one might expect from worlds with magnetic fields interacting with charged particles. No, these are gigahertz frequency radio bursts, thousands of times higher pitched and more energetic than FM radio signals on Earth. On our home planet, radio signals at these extreme frequencies emanate either from sophisticated technological sources or from incredibly energetic astronomical phenomena, like pulsars and quasars. Finding them originating from rogue planets suggests these worlds are experiencing physical processes that do not exist anywhere else in our solar system, processes that push the very boundaries of known physics. The radio emissions appear, unsettlingly, to be linked to the binary nature of these planets. When two massive objects orbit each other, they generate complex gravitational interactions that can, in theory, create powerful magnetic fields and immense electrical currents. Imagine it as a form of cosmic friction, operating on a scale we have never before encountered. The jumbos are, in essence, giant electrical generators, powered by their eternal orbital dance. But the signals themselves remain deeply puzzling, almost personalized. Different pairs of jumbos produce distinct radio signatures, suggesting that each binary system possesses its own unique electromagnetic personality. Some emit steady, rhythmic streams of radio waves, while others produce sporadic, chaotic bursts that defy any apparent pattern. The implications are profoundly unsettling. If these orphaned worlds can generate radio signals this powerful, what else might they be capable of? Their magnetic fields could be orders of magnitude stronger than anything we observe in our solar system, creating space weather phenomena that could ripple across the interstellar medium, potentially affecting nearby star systems. Even more disturbing is what the sheer existence of so many jumbos suggests about planetary system formation itself. If hundreds of these paired worlds exist in just one nebula, there could be millions, or even billions of them scattered throughout our galaxy, each one a silent monument to a failed solar system, a cosmic tragedy where gravitational interactions went spectacularly wrong, ejecting entire planets into the eternal night. These rogue worlds are cosmic orphans, forever separated from the warmth and life-giving energy of stellar companionship. They exist in perpetual darkness, their only sources of heat emanating from the slow, agonizing decay of radioactive elements deep within their cores, and the relentless tidal forces generated by their desperate orbital dance with their companion. But as disturbing as these wandering planets are, Webb discovered worlds that challenge our understanding of planetary formation in even more fundamental ways. The next discovery would force scientists to reconsider everything they thought they knew about how planets form around young stars. A young star system is defying the basic rules of planet formation, almost maliciously, by creating worlds made of the wrong materials. In the star-forming region known as NGC 6357, James Webb discovered a planet-forming disk that contains almost no water, yet is shockingly rich in carbon dioxide, precisely in the inner regions where Earth-like planets should be coalescing. This finding shatters one of the most fundamental assumptions underpinning how rocky planets develop around young stars. Every model of planetary formation, every theoretical framework, assumes that the inner regions around young stars, where terrestrial planets typically form, should be dominated by water ice and silicate minerals. Water is, after all, one of the most abundant molecules in the universe, and its ubiquitous presence in planetary disks is considered absolutely essential for creating the kinds of worlds that could potentially support life as we know it. The disk around the star Zu-10, however, throws all of these deeply held assumptions into profound chaos. When Webb examined this system using its near-infrared spectrograph, astronomers fully expected to see the familiar, comforting signature of water vapor, mixed with other common compounds. Instead, they found a disk where carbon dioxide reigns supreme in the inner regions, dominating the very zone where rocky planets typically form. Water is so scarce, so vanishingly rare, that it is barely detectable, creating an environmental chemistry unlike anything scientists have ever modelled or conceived. This discovery directly challenges everything we understand about planetary formation chemistry. On Earth, water played an absolutely crucial, indispensable role in shaping our planet's geology, forming its atmosphere, and ultimately creating the very conditions that allowed life to emerge. A planet forming in the Xui-10 system would develop under radically different chemical conditions, potentially creating types of worlds that have no analogue, no counterpart in our own familiar solar system. Two theories attempt to explain this bizarre chemistry, and both carry unsettling implications for the prevalence of life in the cosmos. The first suggests that intense ultraviolet radiation, either from the young star itself or from massive nearby stars, has essentially sterilized the disk, breaking apart water molecules and driving the volatile hydrogen away, while leaving oxygen free to combine with carbon. This would be a cosmic sterilization event, preventing the very building blocks of life from forming. The second theory is even more disturbing. The carbon dioxide dominance might stem from unusual conditions in the dust grains that comprise the planetary disk. Instead of being coated with water ice, like dust grains in normal systems, these particles might be covered entirely with carbon dioxide due to the specific extreme environmental conditions around this particular young star. Either explanation suggests that planetary formation can follow pathways that astronomers never imagined, pathways that could dramatically alter the potential for life. If ultraviolet radiation can so effectively strip water from planet-forming disks, it means that many potentially habitable worlds might never acquire the crucial chemical building blocks they need to support life. The galaxy could, terrifyingly, be filled with dry carbon dioxide-rich planets that formed under conditions fundamentally hostile to the chemistry we associate with life. This discovery also raises profound questions about the diversity of planetary systems throughout the galaxy. If planet formation can produce such dramatically different chemical environments, there might be entire classes of worlds out there that operate according to geological and atmospheric processes we have never encountered, worlds truly alien to our experience. The Q10 system, therefore, represents a natural, albeit disturbing laboratory for studying alternative planetary formation pathways. As the planets in this system continue to develop, they will provide invaluable, perhaps terrifying insights into how worlds form when the basic chemical ingredients are fundamentally different from what we observe in our own solar system. But the strange chemistry of planet formation was just one of many atmospheric mysteries that Webb would uncover. The telescope's next target would reveal a world so hostile, so utterly alien, that it challenges our very definition of what constitutes a planetary atmosphere. As a world so incredibly close to its star that its surface glows like molten metal, somehow maintains an atmosphere that defies every known law of planetary science. The exoplanet 55 Cancri E orbits its parent star with such astounding proximity that it completes a full year in a mere 18 Earth hours. This hell planet is tidally locked, meaning the same scorching side perpetually faces its star, creating a day side hot enough to melt copper and a night side plunged into eternal frigid darkness. Surface temperatures soar to over 4,000 degrees to 200 D and hot enough to vaporize most known materials. By every established rule of planetary physics, this world should have been stripped bare of any atmosphere billions of years ago by the relentless stellar winds of its sun. Yet James Webb discovered something impossible. This hell planet not only possesses an atmosphere, but it is composed of materials that, by all rational understanding, shouldn't be able to exist as gases at such extreme temperatures. The atmosphere appears to be astonishingly rich in carbon monoxide and carbon dioxide, forming a thick, oppressive blanket around a world that, logically, should be as airless as Mercury. The discovery emerged through careful, meticulous temperature measurements using Webb's mid-infrared instrument, MIRI. When astronomers measured the thermal emissions from the planet's day side, they found it was significantly cooler than expected. Something was actively blocking and redistributing the star's ferocious heat, and that something could only be an atmosphere, a thick, robust atmosphere, capable of transporting immense amounts of energy from the scorching day side to the frozen, eternal night side. This atmospheric circulation creates one of the most extreme weather systems ever discovered in the cosmos. Imagine winds howling at thousands of miles per hour, carrying vaporized rock and metal from the infernal day side to the frigid night side, where these materials condense and fall as rain made of molten minerals. The theoretical temperature difference between the day side and night side should exceed 3000 degrees Celsius, 1650 degrees, a difference that would annihilate anything in its path. But the atmosphere somehow moderates this brutal disparity through convection currents that operate under conditions no Earth-based laboratory could ever replicate, pushing the boundaries of material science. What makes this atmosphere truly impossible, almost an affront to physics, is its very source. The Hell planet's atmosphere cannot be a remnant from its formation, because the fierce solar winds from its nearby star would have stripped away any primordial gases within a mere few million years. Instead, researchers believe this is a secondary atmosphere, continuously bubbling up from the planet's violently churning interior. Picture a world where the very crust itself is boiling, relentlessly. The intense heat and relentless tidal forces from the nearby star are literally cooking the planet's interior, causing carbon-rich materials deep underground to vaporize and escape through a continuous process of volcanic outgassing. This atmosphere is constantly being destroyed by stellar radiation, and simultaneously, constantly being replenished by geological processes operating at temperatures that would vaporize most known materials. This creates a hellish, cyclical process where the planet's own interior feeds its impossible atmosphere. Rock vapor rises from the surface, is then violently blown around the planet by supersonic winds, condenses on the night side, and rains back down as liquid metal and stone. The entire world has become a massive planet-sized distillation apparatus, operating under conditions that push the very boundaries of what physics allows. The existence of 55 Cancri's atmosphere suggests that planets can maintain gaseous envelopes under far more extreme conditions than scientists previously thought possible. This has profound implications for our understanding of potentially habitable worlds. If atmospheres can survive in such hellish environments, they might also persist around planets that we have historically written off as too hostile for any kind of atmospheric chemistry, opening up entirely new classes of exoplanets for study. But the Hell planet's impossible atmosphere was just a warm-up for Webb's next discovery. The telescope was about to encounter a visitor from another star system that would challenge our understanding of time itself. An ancient comet from another star system is hurtling through our solar system, an ethereal messenger older than Earth, older than the Sun, older than everything we call home. Comet 3I Atlas appears unremarkable at first glance. It's approximately 7 miles wide, composed of familiar ice and rock, and follows a trajectory that will eventually carry it past our Sun before returning to the fathomless void between stars. But James Webb's detailed spectroscopic analysis revealed something that shouldn't be possible. This interstellar visitor is approximately 7 billion years old, making it a staggering 3 billion years older than our entire solar system. When astronomers painstakingly tracked the comet's steep trajectory through space, they realized it originated from the Milky Way's thick disk, a region of our galaxy teeming with ancient stars that formed when the universe was significantly younger. This cosmic wanderer has been drifting through interstellar space since before our Sun was even a glimmer, a nascent spark in a stellar nursery. It predates Earth, Mars, Jupiter, and every single planet in our cosmic neighbourhood. Webb's near-infrared spectrograph revealed that the comet's coma, the cloud of gas and dust surrounding its nucleus, is dominated by carbon dioxide rather than the water vapour typical of comets from our own solar system. This unusual, almost alien composition provides crucial clues about the chemical environment of the star system, where it formed billions of years ago. The comet is travelling at an astonishing speed of over 130,000 miles per hour, fast enough to traverse the entire continental United States in less than 2 minutes. Its trajectory is unusually flat and straight, unlike anything else in our gravitationally bound solar system. This interstellar intruder follows the majestic gravitational rules of the galaxy, rather than being confined by our Sun's influence, treating our entire solar system as just another minor obstacle to navigate around. What makes this ancient visitor truly unsettling is what it represents. 3I Atlas is a direct messenger from a time when the universe was radically different from today. 7 billion years ago, the Milky Way was a far more chaotic, violent place. Star formation rates were significantly higher, heavy elements were scarcer, and the complex chemical processes that build planets operated under dramatically different conditions. This comet formed around a star that lived and died billions of years before our Sun even flickered into existence. It survived the violent death of its parent star, possibly a cataclysmic supernova explosion that utterly destroyed its original solar system and sent it wandering, forever adrift, through the galaxy. For 3 billion years it journeyed through the cosmic deep, a frozen time capsule carrying the pristine chemical signatures from an ancient, long-lost epoch. The fact that we are seeing it now raises profoundly disturbing questions about how many other ancient visitors might be silently passing through our solar system, completely undetected. 3I Atlas is only the third confirmed interstellar object ever discovered, but rigorous statistical models suggest that dozens, perhaps hundreds, of these cosmic time travelers should be crossing our neighborhood at any given moment. Each represents a fragment of a destroyed world, a piece of cosmic history that survived catastrophes we can barely imagine. They are archaeological artifacts from stellar systems that existed when the universe was young, carrying invaluable information about galactic conditions from epochs that no other objects can provide. But 3I Atlas also serves as a stark, chilling reminder of our own solar system's ultimate inevitable fate. In a few billion years, when our Sun begins its slow, agonizing death, objects from our world might be violently ejected into interstellar space, becoming ancient wanderers that will puzzle astronomers in distant galaxies long after Earth is gone, a cosmic echo of a vanished home. The ancient comet's visit was a fleeting preview of cosmic timescales that utterly dwarf human understanding. But Webb's surveys revealed objects even more mysterious than ancient visitors from dead star systems. 300 mysterious objects are glowing with an impossible light in the early universe, and astronomers, in a rare admission of profound bafflement, simply can't figure out what they are. James Webb's deep surveys have uncovered a new, utterly enigmatic population of cosmic objects that defy classification, refusing to fit into any known astronomical category. These little red dots appear as tiny crimson pinpricks of light, scattered inexplicably throughout images of the early universe, but their properties are so unusual, so utterly contradictory, that scientists are struggling to impose any logical framework upon them. Each one is far brighter than it should be, given what we know about the slow, laborious processes of galaxy and star formation in the universe's youth. The mystery deepens with their very colour. In astronomy, red light typically indicates either immense distance, redshift, or cool temperatures. These objects are undeniably distant, existing when the universe was less than 1 billion years old, but they are also incredibly luminous, radiating enormous amounts of energy through unknown processes, creating a combination of properties that simply does not match any object in the modern, well-understood universe. Using advanced techniques like infrared imaging and spectral energy distribution analysis, astronomers at the University of Missouri painstakingly identified 300 of these enigmatic objects in Webb's treasure trove of data. Each one appears to be roughly the size of early galaxies, but inexplicably produces far more light than any galaxy formation model predicts. If they are galaxies, they are unlike any that exist today, or any that our theories can account for. The objects are so preternaturally bright that they are forcing scientists to fundamentally reconsider how galaxies could have formed in the early universe. Traditional models assume that the first galaxies grew slowly, gradually accumulating matter through gravitational collapse over hundreds of millions of years. The little red dots, however, suggest that some unknown process was creating massive luminous structures much more rapidly, far exceeding the pace current theories allow. But here is where the mystery deepens into something truly disturbing. When astronomers attempt to determine precisely what is producing all this impossible light, the answers simply don't make sense. Some of the objects appear distinctly point-like, strongly suggesting they might be powered by supermassive black holes, rather than the distributed light of star formation. Others, conversely, show evidence of extended structure, indicating they might be genuine galaxies undergoing extraordinarily rapid, almost violent star formation. The most disturbing possibility, the one whispered in hushed tones, is that these objects represent a completely unknown phase of cosmic evolution, a period in the universe's history we have no framework for. During the universe's first billion years, physical conditions were drastically different from today. matter was denser, dark matter interactions were arguably more frequent, and the cosmic web of large-scale structure was still forming its intricate patterns. Perhaps these unique, primordial conditions allowed for types of object formation that simply cannot happen in the modern universe. Some of the little red dots show evidence of extremely high-energy processes. They emit X-rays, ultraviolet radiation, and infrared light in patterns that suggest violent, chaotic energy production. Whatever is powering these objects is operating under extreme conditions that push the very boundaries of known physics. The objects also appear to be distributed randomly throughout space, rather than clustered in regions where early galaxy formation was theoretically expected to occur. This random, almost anarchic, distribution suggests they might represent a fundamental property of the early universe, rather than rare, isolated phenomena. Bang Jiang-sun, the graduate student spearheading this groundbreaking research, emphasizes that even if only a few of these objects are confirmed to exist in the early universe, they will force scientists to radically modify existing theories of galaxy formation. The sheer number of mysterious objects Webb has found suggests that our understanding of cosmic evolution during the universe's youth is fundamentally, tragically incomplete. The little red dots represent perhaps the most significant enigmatic challenge to cosmology that Webb has yet discovered.
Analysis to understand
but their mystery, as profound as it is, pales in comparison to what the telescope found when it looked at the large-scale structure of the universe itself. Galaxies across vast, unimaginable regions of space are spinning in synchronized patterns that suggest the universe might, inexplicably, have been born rotating. In what may be James Webb's most mind-bending, paradigm-shattering discovery, astronomers have unearthed compelling evidence that galaxies, separated by millions of light-years, distances so vast that light from one would take millions of years to reach another, are rotating in coordinated patterns. This cosmic choreography, this impossible ballet, brazenly defies our understanding of how structure forms in the universe and raises the chilling possibility that the entire cosmos was born with a preferred direction of rotation, an innate spin. The discovery emerged from meticulous observations of 263 galaxies, captured during Webb's Advanced Deep Extragalactic Survey. When astronomers painstakingly analysed the orientation and rotation patterns of these distant star systems, they found something that, according to standard cosmological models, should be utterly impossible. Galaxies that are far too distant to exert any gravitational influence on each other are inexplicably spinning in similar directions. Imagine discovering that every windmill across an entire continent is, impossibly, turning in exactly the same direction, even though there's no discernible wind pattern that could possibly coordinate their motion. Yet, these galaxies, separated by cosmic chasms, are all participating in the same grand, synchronized cosmic dance. Dr. Lior Shamir, the computer scientist who led this revelatory analysis, identified two primary explanations for this perplexing phenomenon, and both are deeply unsettling for conventional cosmology. The first, and perhaps most disturbing, is that the universe itself was born rotating. If the Big Bang, the very genesis of our reality, possessed angular momentum, it could have imprinted a preferred rotational direction on the cosmic structure that formed afterward. This explanation aligns, chillingly, with black hole cosmology, a radical theory suggesting that our entire observable universe might, in fact, be the interior of a massive black hole within a larger parent universe. If true, the rotational patterns Webb observed could be direct evidence of the parent black hole's spin, transmitted across cosmic scales through mechanisms we do not yet understand. The second explanation is even more disturbing for conventional cosmology. If the universe wasn't born rotating, then the coordinated galaxy spins suggest that existing theories about cosmic evolution are fundamentally, catastrophically incomplete. Some unknown force or field, operating on scales larger than anything scientists have previously considered, must be dictating this cosmic alignment. The implications of a rotating universe extend far beyond mere galaxy formation. A universe with a primordial spin would possess different physical properties than the static, isotropic cosmos described by standard models. Space and time themselves might have preferred directions, creating subtle, yet profound asymmetries in physical laws that could affect everything from particle physics to the ultimate grand fate of the universe. The discovery also raises unsettling questions about dark energy, the mysterious force currently invoked to explain cosmic expansion. If the universe has a preferred rotational axis, dark energy's effects might vary depending on direction, creating a cosmos that expands faster in some directions than others. This could, ironically, explain some of the very anomalies Webb has found in cosmic expansion rates, tying several impossible mysteries together. Perhaps most unsettling is what a rotating universe suggests about our true place in the cosmic hierarchy. If our universe is spinning inside a larger structure, it implies that reality extends far beyond the observable cosmos. We might be living inside just one component of an incomprehensibly vast multiverse, where entire universes rotate like galaxies within some higher dimensional space. The coordinated galaxy rotations represent a fundamental challenge to our understanding of cosmic structure formation and the very nature of space itself. But the universe's hidden rotations were just the beginning of Webb's assault on conventional physics. The telescope's next discovery would reveal black holes forming through processes that, by all logic, shouldn't be possible. A supermassive black hole is forming in the real time through a process that shatters every rule of stellar evolution. Deep in the cosmos, James Webb discovered a galactic collision that is actively creating something unprecedented. The system, which astronomers have named the Infinity Galaxy, hosts a supermassive black hole that appears to have formed through direct gravitational collapse, rather than the protracted death of massive stars. This process, unimaginably violent and rapid, is unfolding in a location where no black hole should be able to exist. The black hole sits suspended in a vast expanse of glowing hydrogen gas, precisely between two colliding galactic nuclei. In normal galaxy mergers, the supermassive black holes from each galaxy eventually spiral toward each other, creating binary systems that either merge into an even larger single entity or, in rarer cases, eject one black hole entirely from the system. The Infinity Galaxy breaks this pattern, defiantly hosting a black hole in a gravitational no man's land. Dr. Pieter van Dokkum and Dr. Gabriel Bramer identified this system while examining Webb's deep field images. The galaxy's distinctive figure-8 shape immediately caught their attention. Follow-up observations, particularly radio emissions, revealed something far more significant. The radio signals pinpoint a massive black hole, existing exactly where theory says it shouldn't be able to survive, a cosmic phantom defying gravitational logic. The direct collapse process works like a cosmic avalanche, a catastrophic chain reaction. When the two galaxies violently crashed together, they created enormous turbulent streams of gas flowing between their cores. Under precisely the right extreme conditions, these gas streams became so massive and incredibly dense that they collapsed directly into a black hole without ever forming stars. It is, quite literally, gravitational collapse without the intermediate time-consuming step of stellar evolution. This discovery solves one of Webb's most puzzling findings. The telescope has found supermassive black holes throughout the early universe that are far too massive for their apparent age. Traditional black hole formation requires patiently waiting for massive stars to form, evolve and die in spectacular supernova explosions. That entire process takes hundreds of millions of years. But Webb has found mature, supermassive black holes existing a mere 600 million years after the Big Bang, a cosmic impossibility by previous calculations. Direct collapse black holes can achieve supermassive status much more quickly, because they begin with enormous amounts of primordial material. Instead of starting as stellar mass black holes and slowly growing through accretion, they form with masses potentially millions of times greater than our Sun, granting them an astronomical head start. This allows them to become the colossal monsters Webb observes in the early universe, defying all timelines. The Infinity Galaxy represents a real-time laboratory for studying this exotic formation process. The black hole is actively feeding on gas flowing between the colliding galactic cores, visibly growing larger as astronomers watch, a live feed of cosmic violence. The system unequivocally demonstrates that black hole formation can be far more dynamic, more rapid, and ultimately more terrifying than scientists previously imagined. But the direct collapse mechanism raises profoundly disturbing questions about the sheer cosmic violence that characterized the universe's youth. If such processes were common in the early cosmos, it means galaxy formation was accompanied by catastrophic events that could instantly create some of the most massive objects in the universe. The process also suggests that supermassive black holes might be more fundamental to cosmic structure than previously thought. Instead of forming as mere byproducts of galaxy evolution, they might be primary drivers of how matter organizes on the larger scales. The Infinity Galaxy's direct collapse black hole proves that the universe possesses mechanisms for creating massive objects that operate far faster and more violently than conventional models predict. But even this rapid black hole formation couldn't explain the most extreme feeding behavior Webb was about to discover. The telescope's next target would reveal a cosmic monster, consuming matter at rates that physics says should be impossible. A black hole in the early universe is devouring matter 40 times faster than the very laws of physics allow, and it's growing at an impossible, terrifying rate. Hidden among thousands of X-ray sources in deep space, James Webb identified a supermassive black hole that is brazenly breaking fundamental rules about how quickly these cosmic monsters can feed. The object, designated ELID 568, is consuming matter at 40 times its theoretical Eddington limit, a rate so extreme, so utterly unprecedented, that it challenges our very understanding of black hole physics. Every black hole has what scientists call an Eddington limit, the maximum rate at which it can accrete matter without the intense radiation pressure from superheated gases blowing away its food supply. Imagine trying to drink from a fire hose. Beyond a certain flow rate, the pressure becomes so intense that it physically prevents further consumption. Lid 568 is, impossibly, drinking from 40 fire hoses simultaneously. The discovery required a unique combination of Webb's unparalleled infrared sensitivity and crucial data from NASA's Chandra X-ray Observatory. ELID 568 was initially buried among thousands of bright X-ray sources, invisible to optical telescopes, but blazing fiercely in high-energy radiation. Webb's unique infrared capabilities allowed astronomers to identify the faint telltale counterpart emissions that revealed the object's true, monstrous nature. What makes this black hole's feeding frenzy truly disturbing are the implications for its growth rate. At such extreme accretion rates, ELID 568 could have gained most of its current colossal mass in a single, relatively brief, episode of rapid feeding. The black hole appears to be undergoing what astronomers call a feeding episode, voraciously consuming enormous amounts of matter in a relatively short cosmic time span. The object exists just 1.5 billion years after the Big Bang, when the universe was still in its infancy. For a black hole to reach supermassive status so quickly, while respecting normal feeding limits, would necessitate starting from impossibly large seed masses, a cosmic absurdity. LED 568's extreme feeding rate provides a potential solution to this cosmic timing problem. The sheer speed and volume of material flowing away from the black hole suggests that substantial portions of its mass growth occurred during similar intense feeding frenzies. These are not gradual accretion processes spread over billions of years, but violent, catastrophic consumption events that can increase a black hole's mass by enormous factors in mere cosmic eye blinks. The physics of such extreme feeding remains profoundly poorly understood. The black hole is somehow stabilizing the accretion process despite radiation pressures that, by all known physics, should blow away its entire food supply. Either the black hole has developed some exotic, unknown mechanism for controlling radiation pressure, or the surrounding matter possesses properties that allow it to miraculously resist being blown away. LID 568 represents the absolute extreme end of black hole feeding behavior, operating under conditions that push physics to its very breaking point. The discovery suggests that the early universe hosted feeding events far more violent and rapid than anything observed in the modern cosmos. These fast-feeding phantoms could explain how supermassive black holes reach their enormous sizes so quickly in cosmic history. Instead of slow, steady growth over billions of years, they underwent brief but incredibly intense feeding episodes that increased their masses by factors of 10 or more. But ELID 568's impossible feeding rate was just one example of the bizarre behavior Webb was finding throughout the early universe. The telescope surveys were revealing that the cosmos's youth was far more chaotic, more violent, and ultimately more unpredictable than anyone had ever imagined. Massive galaxies are sitting dead and silent in regions of space where they should be blazing with furious star formation, and astronomers, in a state of growing alarm, simply can't explain why they stopped growing. James Webb has discovered what researchers are chillingly calling sleeping beauty galaxies, scattered throughout the early universe. These are massive star systems that mysteriously, inexplicably, shut down their star formation processes precisely when they should have been in their most active, vigorous phase. These cosmic giants contain billions of stars, yet show no discernible signs of creating new ones, brazenly defying every model of how galaxies evolved during their youth. The discovery emerged when astronomers meticulously examined galaxies that formed between 600 million and 6 billion years after the Big Bang. During this period, the universe was rich with gas and dark matter, creating theoretically ideal conditions for rapid, prolific star formation. Most galaxies from this era should, by all accounts, be blazing with the fierce light of newly formed stars, consuming available gas at furious rates to build their stellar populations. Instead, Webb found numerous massive galaxies that appear to have fallen into a profound, inexplicable cosmic hibernation. These systems contain stellar masses comparable to our own Milky Way, but show none of the vigorous star formation expected from young, energetic galaxies. They are like massive, bustling cities where all construction suddenly mysteriously stopped for no apparent reason. The Sleeping Beauty nickname stems from their dormant state during what should have been their most active, productive period. Like the fairy tale princess who fell into an enchanted sleep, these galaxies stopped growing at the height of their theoretical development. But unlike the fairy tale, there is no obvious, comforting explanation for what caused their cosmic slumber. Several theories attempt to explain this bizarre behavior, and each one challenges fundamental assumptions about galaxy evolution. The first suggests that supermassive black holes at the centers of these galaxies became so hyperactive that their immense energy output heated the surrounding gas to temperatures too hot for star formation. This process, known as active galactic nucleus feedback, can indeed shut down star formation across entire galaxies. But the timing doesn't match. The Sleeping Beauty galaxies show signs of having shut down their star formation before their central black holes became active enough to cause such widespread heating. Something else, something unknown, must have triggered their dormancy. A second theory proposes that these galaxies consumed their gas supplies so rapidly during an initial frantic burst of star formation that they literally ran out of fuel, a cosmic famine. This explanation, however, requires star formation rates far higher than current models predict, suggesting that early galaxies could build stars much more efficiently, perhaps even violently, than modern systems. The most disturbing possibility is that the Sleeping Beauty galaxies encountered some completely unknown process, a cosmic kill switch that simply does not exist in the modern universe. The early cosmos operated under drastically different physical conditions, with higher matter densities and different dark matter distributions. Perhaps these unique, primordial conditions allowed for star formation shutdown mechanisms that we have never observed, mechanisms that have since vanished from the cosmic stage. The existence of dormant galaxies in the early universe has profound implications for our understanding of cosmic evolution. If massive galaxies could shut down their growth processes so early in cosmic history, it suggests that galaxy formation is far more complex, more capricious, and ultimately more unpredictable than scientists previously believed. These cosmic sleeping beauties represent another unsettling piece of evidence that the early universe was a far stranger, more violent, and less orderly place than our models predict. A rogue planet drifting through space has developed the most bizarre atmosphere ever discovered, with separate cloud layers made of iron and magnesium minerals. Simpsia 136+933 is unlike any world in our solar system, an alien anomaly. This cosmic wanderer does not orbit a star, but instead drifts freely through the galaxy, illuminated only by the faint internal glow of its own residual heat. James Webb's detailed atmospheric analysis revealed something unprecedented, something that defies all planetary science. This rogue planet possesses a layered atmosphere where, impossibly, iron rain falls through clouds made of magnesium minerals. The planet's atmosphere resembles a cosmic layer cake, but one composed of death and fire, with different types of metallic clouds stacked at various altitudes. Near the surface, a dense, oppressive layer of iron clouds creates weather patterns unlike anything on Earth. These are not wisps of water vapor, but thick concentrations of vaporized metal that condense and fall as liquid iron rain during the planet's ferocious storms. Higher in the atmosphere, a second cloud layer, composed of forsterite, a magnesium-rich mineral commonly found in meteorites, creates an entirely different, equally alien weather system. These silicate clouds form when temperatures and pressures reach exactly the right, extreme conditions for magnesium compounds to vaporize and then condense. The interaction between these two distinct cloud layers creates atmospheric dynamics that push the very boundaries of planetary science. Webb's infrared observations reveal that both cloud layers are patchy and constantly changing, suggesting active, violent weather patterns driven by the planet's rotation and its internal heat sources. The iron clouds appear to follow different circulation patterns than the magnesium clouds, creating a complex three-dimensional atmospheric structure that varies dramatically across the planet's surface. But the most mysterious, and arguably most disturbing aspect of this world's atmosphere comes from high above both cloud layers, where Webb detected what researchers are calling hot spots. These are regions of intense heat that appear to be powered by radio auroras, electromagnetic phenomena similar to Earth's northern lights, but operating at energy levels that would be instantly lethal to any known form of life. The radio auroras strongly suggest that SIMP 0136 Pulsro 933 possesses an incredibly powerful magnetic field, far stronger than anything in our solar system. This magnetic field interacts violently with charged particles in interstellar space, creating electrical currents that heat portions of the upper atmosphere to temperatures exceeding those found in the metallic cloud layers below. Dr. Alison McCarthy, the graduate student leading the atmospheric analysis, described the planet as having variability mechanisms that had been hypothesized but never directly observed. The complex, terrifying interactions between iron clouds, magnesium clouds, and radio auroras create an atmospheric system that operates according to principles we have never before encountered. The existence of such complex atmospheric chemistry on a rogue planet raises profoundly disturbing questions about planetary formation and evolution. SIMP 0136 Plan 933 somehow developed and maintained this elaborate, extreme atmosphere while drifting through the cold, empty abyss of interstellar space, far from any stellar energy source. This suggests that rogue planets might be capable of supporting much more complex atmospheric processes than scientists previously imagined. If one wandering world can develop iron, rain, and magnesium clouds, there could be millions of similar objects throughout the galaxy, each hosting unique alien atmospheric phenomena that we have never even considered possible. The metallic rain world represents a new, terrifying category of planetary atmosphere that challenges our understanding of what kinds of weather systems can exist in the universe. A bizarre galaxy, shaped uncannily like a cosmic owl, is swimming through deep space, revealing tentacled structures that suggest violent interactions we've never seen before. When James Webb captured images of what astronomers playfully nicknamed the cosmic owl, they initially focused on its distinctive, almost artistic appearance. The galaxy's bright central region creates the illusion of two glowing eyes, while surrounding gas and dust formations eerily resemble the feathered outline of an owl's face. But detailed analysis revealed that this cosmic creature is far more alien, more disturbing, and more violent than its whimsical nickname suggests. The cosmic owl belongs to a class of objects called jellyfish galaxies, systems that appear to be swimming through space with long, ethereal tentacles of gas and stars streaming behind them. These tentacles are not merely decorative features, they are direct, harrowing evidence of violent stripping processes that are literally tearing the galaxy apart as it moves through its environment. The galaxy is undergoing a process called ram pressure stripping, where its relentless motion through the hot, dense gas-filling galaxy clusters creates a cosmic headwind that literally blows away significant portions of the galaxy's structure. Imagine driving a convertible at highway speeds while loosely packed cargo flies out of the back seat. The cosmic owl is losing parts of itself as it travels through space, a slow, agonizing disintegration. Webb's infrared vision revealed the true, horrifying extent of this cosmic violence. The galaxy's tentacles stretch for hundreds of thousands of light years, containing billions of stars that have been ripped away from their original homes. These stellar refugees now exist in the tentacles, isolated from the galaxy's main body, and slowly dispersing into the vast, indifferent void. But the most disturbing aspect of the cosmic owl isn't what it's losing, but what the stripping process reveals about galactic environments. The ram pressure required to create such extensive, elongated tentacles indicates that the galaxy is moving through an incredibly dense and hot medium, far more extreme than the relatively empty space between galaxies. This suggests that the cosmic web, the large-scale structure of matter that connects galaxies across the universe, is far more violent, more turbulent, and less hospitable than scientists previously realized. Instead of galaxies moving serenely through empty space, they are fighting their way through environments that can literally tear them apart atom by atom. The jellyfish process also, paradoxically, creates new opportunities for star formation within the tentacles themselves. As gas is stripped from the galaxy and compressed by the ram pressure, it can trigger intense bursts of star formation in locations far from the galaxy's main body. The cosmic owl is simultaneously being destroyed and in its wake creating new stellar populations. Webb's observations revealed active star formation regions scattered throughout the galaxy's tentacles, glowing bright blue with the fierce light of young, massive stars. These stellar nurseries exist in gravitational isolation, billions of light years from the galaxy that originally provided their raw materials. The discovery of extensive jellyfish structures throughout Webb's deep field images suggests that galactic cannibalism and stripping processes are far more common, far more fundamental to cosmic evolution than astronomers previously believed. The universe might be filled with cosmic refugees, stars and gas clouds that have been violently torn away from their parent galaxies and now drift aimlessly through the void. The cosmic owl represents just one terrifying example of the violence that shapes galactic evolution on the largest scales. But even this galactic destruction pales in comparison to the stellar violence Webb discovered happening within individual star systems. Young stars are creating heavy elements that by all established timelines shouldn't exist yet, forging cosmic chemistry that defies our understanding of stellar evolution. James Webb has discovered young star systems producing heavy elements like oxygen, carbon, and nitrogen at levels that should be impossible given their apparent age. These stellar nurseries are creating complex chemistry that, according to every model of stellar evolution, requires billions of years to develop through successive generations of star formation and death. The mystery centers on metallicity, the astronomical term for elements heavier than hydrogen and helium. In the early universe, only these two lightest elements existed in significant quantities. All heavier elements, from carbon and oxygen to iron and gold, had to be forged in the nuclear furnaces of massive stars and then dispersed through space when those stars exploded as supernovae. This process, crucially, should take time, billions of years of cosmic recycling. The first generation of stars, dubbed Population 3 stars, would have been made almost entirely of hydrogen and helium. When they died, they enriched the surrounding space with newly created heavy elements, allowing the second generation of stars to form with slightly more complex chemistry. This cosmic recycling process continues over billions of years, gradually increasing the metallicity of star-forming regions. Webb, however, has found star systems that appear to have skipped several steps in this process. Young galaxies that formed when the universe was less than 1 billion years old show metallicity levels that should require multiple generations of stellar evolution. They're producing oxygen, carbon, and nitrogen at rates that simply don't match their apparent age, a cosmic violation of the evolutionary timeline. The most extreme example comes from the galaxy JSG-SC 131, observed a mere 330 million years after the Big Bang. Spectroscopic analysis revealed bright hydrogen emission lines and unequivocal evidence of heavy element production that suggests the galaxy had already undergone significant stellar evolution, despite existing during cosmic infancy. This impossible chemistry forces scientists to radically reconsider fundamental assumptions about early star formation. Either the first generation of stars was far more massive and short-lived than current models predict, allowing them to create and disperse heavy elements much more rapidly, or some entirely unknown process was enriching the early universe with complex chemistry. The first possibility suggests that population 3 stars were cosmic monsters, perhaps hundreds of times more massive than our Sun. These stellar giants would have burned through their nuclear fuel in just a few million years before exploding in hypernovae, explosions far more powerful than supernovae, that scattered heavy elements across vast regions of space. Such massive stars do not exist in the modern universe, but the extreme conditions of the early cosmos might have allowed their formation, a fleeting, violent era. The second possibility is even more disturbing. If unknown processes were creating heavy elements in the early universe, it means our understanding of cosmic chemical evolution is fundamentally, catastrophically incomplete. Some mechanism beyond stellar nuclear synthesis, a process unknown to us, might have been operating during the universe's youth, creating complex chemistry through pathways we have never identified. The rapid metallicity evolution Webb has observed also affects our understanding of planet formation and the potential for early life. If heavy elements became available much sooner than previously thought, rocky planets and the essential chemical building blocks for life might have emerged far earlier in cosmic history, changing the timeline for habitability. These discoveries suggest that the early universe was capable of chemical complexity that makes our current models look like oversimplified approximations of a far more intricate, violent reality. Part 6. The Vanishing Planet and Dark Matter Catastrophes. A world orbiting our nearest stellar neighbour keeps appearing and disappearing in Webb's observations, and astronomers, in a state of profound bewilderment, can't figure out why it exists at all. In what researchers are calling the most significant James Webb finding to date, the telescope detected a giant planet orbiting Alpha Centauri A,
doesn't make any sense. Where is
our
it?
closest Sun-like star,
don't know,
only to
it's
lose
just not
track of it
there.
completely during follow-up observations. This cosmic vanishing act has created one of the most baffling mysteries in exoplanet science, right on our cosmic doorstep. The planet, tentatively designated Alpha Centauri AB, appeared in Webb's initial observations as a thermal signature consistent with a world roughly the size of Neptune, orbiting tantalizingly within the habitable zone of Alpha Centauri A. The discovery would have been groundbreaking enough on its own, representing the closest potentially habitable planet to Earth ever found. But when astronomers attempted to confirm the detection with additional meticulous observations, the planet simply wasn't there. Subsequent imaging sessions showed no trace of the thermal signature that had been so clear, so undeniable in the original data. The planet had either moved to a position where Webb couldn't detect it, or it had somehow ceased to exist entirely, a cosmic sleight of hand. Several explanations have been proposed for this cosmic disappearing act, and each one challenges conventional understanding of planetary systems. The first suggests that the planet has an extremely elliptical orbit that carries it far from its star for most of its year, making it detectable only during brief fleeting periods when it passes close enough to emit significant thermal radiation. But orbital mechanics makes this explanation problematic. A planet with such an extreme orbit around Alpha Centauri A would be gravitationally unstable, almost certainly ejected from the system by interactions with the star's binary companion, Alpha Centauri B. The gravitational dance between two stars creates complex, volatile dynamics that make stable planetary orbits incredibly difficult to maintain. The second explanation is even more
We are
unsettling.
using mathematical
The
equations
planet might
and
be
brain
real,
network
but
analysis
surrounded
to
by a
understand
variable dust
cosmic
cloud or debris
magnetism.
ring that periodically obscures it from Webb's sensitive infrared sensors. This would suggest that the Alpha Centauri system is far more dynamically active than previously believed, with ongoing collisions or disruptions creating temporary opaque veils around orbiting worlds, hiding them from our gaze. A third, almost heretical possibility challenges our understanding of planetary formation entirely. The thermal signature might represent a world that's still forming, actively accreting material from a protoplanetary disk in episodes that make it alternately visible and invisible to infrared observation. This would mean that planet formation is still actively occurring in the Alpha Centauri system, despite the stars being billions of years old, a process thought to have concluded long ago. The most disturbing explanation, the one that hints at true cosmic strangeness, is that Webb detected something that isn't a planet at all. The thermal signature might represent a previously unknown type of cosmic phenomenon, Perhaps a dense cloud of warm debris, or even a failed star formation event occurring in the outer, colder regions of the Alpha Centauri system. The vanishing planet mystery highlights how much we still don't know about planetary systems, even ones in our immediate cosmic neighbourhood. If a world can appear and disappear in observations of our nearest stellar neighbour, it raises profound questions about what other planetary phenomena might be hiding in plain sight, mocking our assumptions. The Alpha Centauri Vanishing Act serves as a stark reminder that space remains full of surprises that challenge our most basic assumptions about how planetary systems work. Ancient magnetic fields discovered throughout the cosmic web are as complex as human brain networks, and they're older than any known structure in the universe. James Webb has detected unequivocal evidence of magnetic fields stretching across the largest structures in the cosmos, creating patterns of connectivity that eerily resemble the neural networks found in human brains. These primordial magnetic fields appear to be remnants from the universe's first billion years, a forgotten era when cosmic structure was still forming through processes we barely understand, if at all. The discovery emerged from Webb's meticulous observations of the cosmic web, the vast, intricate network of filaments and voids that organizes matter on the larger scales, connecting galaxies and galaxy clusters like colossal strands of a nervous system. Thin streams of gas and dark matter create bridges spanning hundreds of millions of light years. Webb found that these cosmic filaments are threaded with magnetic fields of extraordinary, baffling complexity. The magnetic field patterns show a level of organization, a sophistication that simply shouldn't exist in the early universe. Instead of simple, uniform fields, Webb detected intricate networks with nodes, connections, and hierarchical structures that mirror the topology of biological neural networks. The similarity is so striking, so profound, that researchers are now using the very same mathematical tools developed to study brain connectivity to analyze cosmic magnetism, a shocking cross-disciplinary convergence. These ancient magnetic fields raise fundamental, almost philosophical, questions about cosmic evolution. Standard models assume that magnetic fields in space develop gradually as galaxies and stars form, with stellar winds and supernova explosions creating and amplifying magnetic structures over billions of years. The primordial fields Webb discovered appear to predate this entire process, challenging the very timeline of cosmic magnetism. The fields show clear evidence of having influenced early galaxy formation in ways that current theories simply do not account for. Magnetic pressure and powerful magnetic reconnection events might have profoundly shaped how gas collapsed into the first stars, affecting stellar masses, formation rates, and the entire chemical evolution of early galaxies. Perhaps most disturbing is what these brain-like magnetic networks suggest about the nature of cosmic structure formation. The brain-like patterns indicate that the universe developed organizational complexity far earlier than scientists believe possible, an almost emergent intelligence in the cosmic fabric. Instead of simple gravitational collapse creating cosmic structure, the early cosmos might have operated more like a vast organic information processing system, a cosmic computer. The magnetic field networks also appear to be dynamic, almost alive, with connections forming and breaking across cosmic time. Webb detected evidence of magnetic storms spanning entire galaxy clusters, events of unimaginable power that could affect star formation and galactic evolution across vast regions of space. The discovery has profound implications for our understanding of dark matter and dark energy. Magnetic fields can interact with charged particles in ways that affect how matter clumps together on large scales. If primordial magnetism was more complex and powerful than current models assume, it might explain some of the discrepancies Webb has found in cosmic structure formation, offering a unified theory for several anomalies. The brain-like magnetic networks represent a fundamental challenge to our understanding of how complexity emerges in the universe. If such sophisticated organizational structures existed in the cosmic web's youth, it suggests that the universe has intrinsic inherent tendencies toward complexity that we've never recognized, an almost self-organizing property. These primordial magnetic fields might be direct evidence that the universe itself possesses properties analogous to living systems, with information processing and organizational capabilities that emerge from physical processes we don't yet understand, blurring the lines between physics and biology on the grandest scale. A supermassive black hole at the centre of our galaxy is pulsing with irregular rhythms that suggest unknown physics operating at the very edge of space-time. Sagittarius A, the 4 million solar mass black hole at the Milky Way's heart, has quietly surprised astronomers for decades, but James Webb's continuous, unprecedented monitoring revealed something truly unprecedented. The cosmic monster exhibits erratic brightness fluctuations that eerily resemble a heartbeat, yet with no discernible, predictable pattern. Using Webb's near-infrared camera, researchers observed Sagittarius A for 48 hours, spread across multiple sessions throughout 1 year. What they discovered was a black hole in constant, violent flux, with its accretion disk producing a continuous but chaotic series of brightness changes, punctuated by sudden, dramatic flares. The observations showed constantly changing, bubbling brightness across the black hole's event horizon region. Then, without warning, massive bursts of radiation would suddenly erupt from the accretion disk before calming down again, a cosmic temper tantrum. These flares appear completely random, defying every attempt to find underlying patterns or periodicities. Dr. Farhad Youssefzadeh, the Northwestern University professor leading the research, described the behavior as unlike anything previously observed in supermassive black holes. The team found no patterns in the activity, suggesting that the processes driving these brightness changes operate according to physics that current models simply don't fully capture, a hidden layer of reality. Two mechanisms appear to be creating this cosmic heartbeat. Short-term fluctuations likely result from turbulence within the accretion disk, where magnetic field interactions compress plasma and create temporary flashes of radiation. Think of it as cosmic lightning occurring in the superheated gas spiraling toward the black hole's event horizon. But the larger flares suggest something far more dramatic, far more unsettling. These massive brightness increases might result from entire chunks of matter crossing the black hole's photon sphere, the region where light itself begins to orbit the black hole before either escaping or falling past the event horizon forever. The irregular, chaotic nature of these events indicates that Sagittarius A is far more active than astronomers previously realized. Instead of the relatively quiet, slowly feeding monster described in textbooks, the Milky Way's central black hole appears to be in a constant state of low-level violence, consuming matter in unpredictable, terrifying episodes. What makes this behavior truly disturbing is its implications for black hole physics near the event horizon. The brightness fluctuations originate from regions where space and time are severely distorted by gravity, creating conditions where matter and energy behave according to principles that push Einstein's general relativity to its absolute limits, almost to the breaking point. The chaotic nature of the brightness changes suggests that quantum effects might be playing a significant role in black hole accretion processes. Near the event horizon, the boundary between classical and quantum physics becomes blurred, potentially creating phenomena that do not exist anywhere else in the universe, a zone of forbidden physics. The heartbeat pattern also raises profound questions about what happens to information that falls into black holes. If the accretion disk's behavior is truly random, it might indicate that black holes destroy information in ways that violate fundamental principles of quantum mechanics, a deep cosmic paradox. Sagittarius A's irregular pulsing represents our closest, most intimate look at physics, operating under the most extreme conditions the universe can create, where gravity becomes so strong that space and time themselves begin to break down, revealing cracks in reality. Invisible forces are reshaping cosmic structure through violent processes that leave galaxies shredded and scattered across millions of light years. James Webb has uncovered compelling evidence that dark matter, the mysterious substance comprising 85% of all matter in the universe, participates in violent interactions that can tear apart entire galaxies and reshape cosmic structure on the larger scales. These dark matter catastrophes operate through mechanisms that remain completely invisible, except for their devastating, undeniable effects on normal matter. The evidence comes from Webb's meticulous observations of galaxy clusters, regions where hundreds of galaxies are held together by the immense gravitational influence of massive dark matter concentrations.
This data makes no sense.
When these cosmic cities collide, they create some of the most energetic events in the universe, releasing energies comparable to billions of supernova explosions. But Webb's detailed imaging revealed that the violence extends far beyond the visible collision zones. Galaxies located millions of light-years from cluster collisions show clear signs of having been violently disrupted by gravitational forces that can only be explained by dark matter interactions operating on previously unimaginable scales, a hidden cosmic war. The telescope detected extensive streams of stars and gas connecting galaxies across vast distances, creating bridge-like structures that span the space between separate galactic systems. These stellar streams represent the torn remnants of galaxies that have been gravitationally shredded by dark matter forces during cluster interactions, cosmic victims. What makes this cosmic violence particularly disturbing is its hidden, insidious nature. While normal matter interactions create visible fireworks through electromagnetic radiation, dark matter collisions produce no light, no heat, and no electromagnetic signatures. The only evidence of these catastrophic events comes from their gravitational effects on the matter we can see, the silent screams of dying galaxies. Webb's infrared sensitivity has revealed the full, terrifying extent of this dark violence. Faint stellar streams and tidal tails extend for millions of light-years around galaxy clusters, creating vast ethereal spiderwebs of disrupted matter that previous telescopes were too insensitive to detect. Each stream represents a galaxy that has been partially or completely destroyed by dark matter interactions, a testament to its unseen power. The sheer scale of this destruction suggests that dark matter doesn't simply provide passive gravitational scaffolding for cosmic structure. Instead, it participates actively in reshaping the universe through violent processes that can eject galaxies from their host clusters, strip away their gas supplies, and scatter their stars across intergalactic space, a cosmic act of dismemberment. Computer simulations of dark matter interactions show that these violent events might be fundamental to cosmic evolution. Dark matter particles can undergo collisions and gravitational interactions that create shock waves propagating through the cosmic web, affecting galaxy formation across vast regions of space. Perhaps most unsettling is what this hidden violence suggests about the true nature of dark matter itself. If dark matter can participate in such energetic interactions, it might possess properties beyond simple gravitational attraction. Some models propose that dark matter particles can undergo phase transitions or interact through forces that we haven't yet identified, making it even more mysterious and potentially dangerous. The discovery of widespread dark matter violence also affects our understanding of galaxy evolution and the formation of cosmic structure. If galaxies are constantly being disrupted and reformed through dark matter interactions, the universe might be far more dynamic, more chaotic, and less predictable than our models predict. These invisible catastrophes represent a fundamental aspect of cosmic evolution that operates completely outside our direct observation, shaping the universe through a violence we can only detect through its devastating aftermath. A distant galaxy is bending space-time so severely that it appears in multiple locations simultaneously, creating gravitational effects that challenge our fundamental understanding of general relativity. James Webb discovered a galaxy so incredibly massive and dense that its gravitational field creates multiple, distinct images of itself across the cosmic sky, each showing the same star system at different points in its evolution. This extreme gravitational lensing effect demonstrates space-time curvature operating at levels that push Einstein's general relativity to its theoretical limits, almost to the point of breaking. The phenomenon, known as strong gravitational lensing, occurs when an object becomes so massive that its gravity literally bends the fabric of space-time, acting like a cosmic magnifying glass. Light from more distant objects follows these curved paths, creating distorted or multiple images that can appear in surprising, unexpected locations across the sky. But this particular galaxy creates lensing effects far more extreme than anything previously observed. Webb detected at least 4 separate images of the same background galaxy, each magnified by different amounts and, astonishingly, showing the star system at different epochs in its history. The gravitational field is so powerful, so intense, that light takes different amounts of time to travel along each curved path. This time delay effect means that astronomers are essentially watching the same galaxy's history unfold in multiple versions simultaneously, a live cosmic replay. One image shows the galaxy as it appeared 800 million years ago, while another reveals its structure 1 billion years in the past. The lensing galaxy has inadvertently created a cosmic time machine, displaying stellar evolution across multiple epochs, a window into the past. What makes this discovery truly disturbing is the implied mass distribution of the lensing galaxy. To create such extreme space-time curvature, the galaxy must contain dark matter concentrations far denser, far more clumped than current models predict.
What is going on?
The dark matter appears to be clumped into structures that challenge our understanding of how these mysterious particles interact and organize themselves, hinting at unknown forces. The lensing effects also reveal substructure within the dark matter distribution that shouldn't exist according to standard cosmological models. Instead of smooth, dark matter halos surrounding the galaxy, Webb detected evidence of dark matter, clumps and voids that suggest complex internal dynamics, operating through unknown mechanisms, almost like invisible organs. The time delay measurements between different lensed images provide direct observational evidence of space-time curvature, operating precisely according to general relativity's predictions. But the extreme nature of the lensing pushes these effects into regimes where quantum gravitational effects might begin to influence classical space-time geometry, blurring the lines between the very large and the very small. Perhaps most unsettling is what this discovery suggests about the prevalence of such extreme gravitational environments in the universe. If one galaxy can create space-time curvature this severe, there might be numerous other cosmic regions where space and time are distorted beyond our current ability to model or understand, making reality itself profoundly unstable. The multiple images also reveal that the lensed galaxy itself is undergoing rapid evolution, with star formation rates changing dramatically between the different time epochs visible in each image. This provides unprecedented insights into how galaxies evolve during their most active, turbulent phases. The Time Warp Galaxy represents a natural laboratory for studying general relativity under extreme conditions, revealing how massive objects can literally reshape the geometry of space and time around them. These gravitational effects operate on scales where classical physics begins to break down, potentially revealing new aspects of cosmic structure that exist at the boundary between general relativity and quantum mechanics. Stars throughout the universe are devouring their companions in feeding frenzies so violent they create entirely new types of cosmic explosions. James Webb has captured direct, undeniable evidence of stellar cannibalism occurring throughout the cosmos, revealing that binary star systems often end in catastrophic episodes where one star literally consumes its companion. These cosmic feeding events create some of the most violent explosions in the universe, generating energies that can, for a brief moment, outshine entire galaxies. The process begins when two stars orbit each other closely enough that their outer atmospheres begin to interact, a dangerous cosmic embrace. The more massive star gradually strips material from its companion, creating streams of superheated gas that spiral inward in brilliant,
we must reevaluate our methodology.
What starts as a gradual feeding process can suddenly, violently accelerate into a catastrophic consumption event, a celestial murder. Webb's infrared vision has revealed these stellar feeding frenzies in unprecedented detail. The telescope can peer through the gas and dust that normally obscures such violent events, showing how matter streams from victim stars to their companions in complex gravitational dances that ultimately end in cosmic cannibalism. The most extreme cases involve white dwarf stars, the incredibly dense remnants of dead stars, roughly the size of Earth,
Dr.
but containing
Rees
the mass
stated
of
that
our
the
Sun.
laws of physics might
When these
be
cosmic
wrong.
vampires accrete material from companion stars, they can trigger thermonuclear explosions called Type ER supernovae, events that temporarily outshine billions of normal stars, a cosmic beacon of destruction. But Webb has discovered even more violent stellar cannibalism events involving neutron stars and black holes. When these ultra-dense objects consume companion stars, they create kilonova explosions that forge heavy elements like gold and platinum, while simultaneously releasing gamma-ray bursts that can be detected across billions of light-years, a cosmic alchemy of death. The telescope has documented the complete life cycle of stellar cannibalism. From the initial stages where companion stars begin losing material, through the rapid accretion phases where feeding accelerates dramatically, to the final explosive events that scatter heavy elements throughout space, fertilizing the cosmos for future generations. Perhaps most disturbing is how common these cosmic feeding events appear to be. Webb's surveys suggest that stellar cannibalism might be a fundamental driver of chemical evolution in the universe, responsible for creating and distributing many of the heavy elements essential for planet formation and, crucially, potentially for life itself. The violent nature of these events also affects surrounding stellar nurseries. Stellar cannibalism explosions can trigger or halt star formation across vast regions, creating feedback effects that influence galactic evolution on scales much larger than the original binary systems. Webb has also discovered evidence of failed cannibalism events, where binary systems begin the feeding process but get disrupted before reaching explosive conclusions. These cosmic near misses create exotic stellar remnants with properties unlike any objects in our local galactic neighbourhood, new anomalies for science to ponder. The prevalence of stellar cannibalism forces astronomers to reconsider how binary star evolution affects cosmic chemical evolution. Instead of stars living isolated lives and dying peaceful deaths, many participate in violent feeding relationships that end in catastrophic explosions. These cosmic feeding frenzies represent one of the primary mechanisms through which the universe creates and distributes the heavy elements necessary for complex chemistry and potentially life itself. Evidence is mounting that reality itself breaks down at cosmic scales, revealing fundamental cracks in the very fabric of space-time that challenge our most basic understanding of physics. James Webb's most disturbing discovery might not be any single object, but rather the accumulating, terrifying evidence that space-time itself becomes unstable under the extreme conditions found throughout the cosmos. The telescope has detected gravitational anomalies, unexplained energy signatures, and structural irregularities that strongly suggest the smooth, predictable fabric of space-time described by Einstein's general relativity is far more fragile, far more volatile than anyone imagined. The evidence comes from multiple sources across Webb's surveys. Gravitational lensing effects around some massive objects don't follow precise general relativistic predictions, showing small but persistent deviations that could indicate space-time structure breaking down under extreme gravitational stress, hinting at a deeper, more fractured reality. These anomalies appear near black holes, in the cores of galaxy clusters, and around other massive cosmic structures, precisely where the laws of physics are pushed to their limits. Quantum mechanics predicts that space-time at the smallest scales should be foamy and chaotic, with virtual particles and energy fluctuations creating a turbulent quantum foam that underlies smooth classical geometry. But Webb's observations suggest that this quantum foam might, impossibly, bubble up to macroscopic scales under certain extreme conditions. The telescope has detected unexplained energy emissions from regions where quantum effects shouldn't be observable, including mysterious radiation signatures from black hole event horizons and anomalous heating in galaxy cluster cores. These phenomena might represent quantum foam breaching into classical spacetime during particularly violent cosmic events, a tear in reality. Perhaps most unsettling are Webb's observations of what astronomers call cosmic strings, hypothetical, one-dimensional defects in spacetime that could have formed during the universe's earliest, most violent moments. If these structures exist, they represent fundamental cracks in reality itself, places where spacetime is literally torn or folded in ways that violate our most basic understanding of cosmic geometry. The telescope has identified several tantalizing candidates for cosmic string signatures, including gravitational lensing patterns that cannot be explained by any known distribution of matter or energy.
These
observations suggest that the universe might contain permanent scars from its violent birth, defects that persist as vulnerabilities in space-time structure, like hidden fault lines. Webb has also found evidence of vacuum decay events, regions where the quantum vacuum appears to have transitioned to lower energy states through processes that release enormous amounts of energy. These events could represent fundamental phase transitions in the structure of reality itself, a cosmic recalibration with devastating consequences. The accumulating evidence suggests that the universe operates far closer to the edge of physical stability than previously believed. Under extreme conditions involving massive gravitational fields, high energy densities or exotic matter states, the fundamental structure of space-time might become inherently unstable, prone to fracturing. These quantum foam breaches have profound implications for our understanding of cosmic evolution and the ultimate fate of the universe. If space-time can become unstable under conditions that exist naturally in the cosmos, it raises unsettling questions about whether reality itself might be more temporary, more fragile than we assume.
But the implications...
The discovery of quantum effects operating on cosmic scales also suggests that the boundary between quantum mechanics and general relativity might be more porous, more interconnected than theoretical physics predicts, with revolutionary implications for our understanding of black holes, cosmology, and the fundamental nature of reality itself. The coordinated rotation of galaxies and the strange behavior of cosmic expansion suggest we might be living inside a black hole within a larger universe. The most terrifying possibility raised by James Webb's collective discoveries, the ultimate cosmic conspiracy, is that our entire observable universe might, in fact, be the interior of a massive black hole, existing within a larger, incomprehensibly vast cosmic structure. This black hole cosmology theory, once relegated to the fringes, now compellingly explains several of Webb's most puzzling observations, including the coordinated galaxy rotations and the impossible expansion rate contradictions that have utterly shattered conventional cosmology. The evidence begins with the galaxy rotation patterns Webb discovered during its deep surveys. Galaxies separated by millions of light years are spinning in coordinated directions, a phenomenon that should be impossible unless the entire universe itself has a preferred rotational axis. In black hole cosmology, this eerie coordination would be a direct result of our universe inheriting the angular momentum of the parent black hole that contains us, an echo of a higher dimension. The theory suggests that what we reverently call the Big Bang was actually our universe crossing the event horizon of a massive black hole in a higher dimensional space. From our limited perspective, inside the black hole, this crossing appears as cosmic expansion, the universe rushing away from us. But from the perspective of the larger universe, we are inexorably falling toward the black hole singularity in a process that, due to gravitational time dilation, will take infinite time to an outside observer. This mind-bending scenario elegantly explains the accelerating expansion of space that we currently attribute to dark energy. As we fall deeper into the parent black hole, space-time curvature increases, creating the illusion that expansion is accelerating when we are, in fact, simply approaching regions of more severe gravitational distortion, a cosmic trick of perception. Webb's discovery of primordial black holes that predate star formation also fits seamlessly into the black hole cosmology model. These ancient monsters could be smaller black holes that existed in the parent universe before. We crossed the event horizon, appearing in our cosmic history as primordial objects that formed before normal matter could collapse into stars, a pre-existing cosmic infrastructure. The coordinated galaxy spins that Webb observed across vast regions of space make perfect, terrifying sense if our universe inherited rotational momentum from a spinning parent black hole. The galaxies aren't mysteriously coordinating their motion. They're all participating in the same grand, fundamental cosmic rotation that was imprinted on space-time when our universe formed, a cosmic dance choreographed by unseen forces. Even the expansion rate contradictions that have so deeply puzzled astronomers fit the black hole cosmology model.
No, that can't be right.
Different measurement techniques might be detecting different aspects of our motion through the curved space-time inside the parent black hole, creating apparent contradictions that result from viewing the same phenomenon from multiple, limited perspectives. If black hole cosmology is correct, it means that everything we can observe, from the cosmic microwave background to the most distant galaxies, exists entirely within the event horizon of an incomprehensibly massive black hole. We would be forever separated from the larger universe that contains us, unable to communicate with or affect anything outside our cosmic prison, eternally isolated. The theory also suggests that black holes throughout our universe might themselves contain entire universes of their own, creating a nested hierarchy of cosmic structures where each black hole serves as a gateway to a complete cosmic realm with its own physics, its own evolution, and, terrifyingly, potentially its own forms of life. This possibility fundamentally transforms our understanding of cosmic significance and our place in the broader structure of reality, suggesting that what we call the universe might be just one bubble, one tiny isolated cell in an infinite multiverse of black hole universes. Conclusion. The discoveries James Webb has made don't just challenge our understanding of the cosmos, they fundamentally alter what it means to be human in a universe far stranger, far more violent, and infinitely more dangerous than we ever imagined. Every assumption we've made about our cosmic environment, every comforting certainty, has been utterly shattered by Webb's relentless revelations. We thought we understood how galaxies form, how black holes grow, and how the universe expands. Instead, we've discovered that space is filled with impossible objects, violent, destructive processes, and phenomena that operate according to physics we simply do not comprehend. A cosmic enigma. The universe Webb reveals is not the orderly, predictable cosmos described in textbooks. It's a realm where galaxies can form faster than physics allows, where black holes wander naked through space, and where the very fabric of space-time itself might be fundamentally unstable, prone to tearing. We're not living in a cosmic garden designed for life, but in a violent, chaotic arena where reality itself can and does break down under extreme conditions. Perhaps most unsettling is what these discoveries suggest about our cosmic isolation. If we're living inside a black hole universe, as the evidence increasingly suggests, then we're forever cut off from whatever larger reality contains us. Every signal we send, every exploration we attempt, will remain trapped within our cosmic prison, never reaching beyond. The prevalence of cosmic violence that Webb has revealed also affects our long-term survival prospects. The universe is filled with wandering black holes, rogue planets broadcasting mysterious signals, and stellar cannibalism events that can sterilize entire regions of space. Our galactic neighborhood might be far more dangerous, far more treacherous than we ever realized. The rapid pace of discovery has also revealed how little we actually know about the cosmos we inhabit. Despite centuries of astronomical progress, Webb's first few years of operation have uncovered phenomena that require completely rewriting our understanding of cosmic evolution, tearing up old textbooks. If we've been this wrong about fundamental cosmic processes, what else have we missed? The telescope's discoveries about early galaxy formation and primordial black holes suggest that the universe achieved complexity far earlier than we believed possible. This means that cosmic evolution might follow pathways we've never considered, potentially including the development of intelligence and civilization on timescales, and in environments we've never imagined, changing the very definition of life supporting. But Webb's revelations also offer a glimmer of hope, a desperate possibility. The universe's astonishing capacity for surprise and complexity suggests that cosmic evolution might be far richer, far more diverse than our rigid models predict. If reality can produce impossible galaxies and naked black holes, it might also be capable of creating forms of life and intelligence that operate according to principles we haven't even begun to discover.
What is
expanding the bounds of
to
possibility. The telescope has essentially revealed that we're cosmic infants, living in a universe that operates according to rules we're only beginning to glimpse, hints of a deeper, stranger truth. Every strange object Webb discovers, every impossible phenomenon it reveals, represents an opportunity to expand our understanding of what's truly possible in a cosmos that clearly delights in violating our expectations. Perhaps most importantly, Webb's discoveries remind us that the universe doesn't owe us comprehensibility. Reality operates according to its own alien logic, following principles that might be fundamentally alien to human intuition, beyond our grasp. Our survival and success as a species depends on our ability to adapt our understanding to match the cosmos as it actually exists, rather than as we wish it were. The universe James Webb has revealed is strange, violent, often incomprehensible, and undeniably terrifying. But it's also the only reality we have, and understanding it, no matter how disturbing that understanding might be, represents our best, our only, hope for navigating the cosmic future that awaits.